All right, hey, this is lesson 4 of Unit 2, Topic 1, and this is a lesson about functions. And first question is on a warm-up about mathematical comparisons, basically about ratios and percents. 3 out of 5 students prefer playing football to playing basketball. That would be 60% that prefer playing football. Because 3 out of 5, 3 divided by 5 is 0.6, and 0.6 is the same as 60%. What percent of students prefer playing basketball? Well, that would be everybody else, so that would be 40%, because 60 plus 40 makes 100%. That's the way I like to think of it. Or you could say it's the other 2 out of 5, and 2 divided by 5 is 0.4. The ratio of students wearing yellow and students not wearing yellow is 3 to 7. What fraction of students have on yellow? Well, 3 are wearing yellow out of 10, because there's 3 that are wearing yellow, 7 that are not. That's a total of 10 people combined. What percent of students don't have on yellow? That would be, percent would be the other 70%. 7 out of 10 makes 70%. So in this lesson, like I said before, we're dealing with functions and being able to represent them in different ways. In this case, it's actually graphing that we focus on the most. So yeah, they are making a lot of announcements here after school. If we wanted to determine Andrew's location in the park with respect to time, would this location be a function of time? Yes, it would. And the reason why it is a function is because you can never have 2 locations at the same time. So your 2 variables are location and time. You can't have the same location in 2 different places at the same time. So therefore, each domain can only have 1 range. So this is a function. That's my justification. All right, sketch a graph for the total distance Andrew walked if he walked at a constant rate the entire time. So this would be his distance, and this would be time, and his distance would have increased the entire time at a constant rate. Because no matter if he's walking backwards or forwards or sideways or left, it doesn't matter because his total distance is always increasing at a constant rate. This is total distance. All right, so the third question then asked you, how would it change? How would the graph look if we were comparing time to his distance from the entrance? I'm kind of rushing here, so you just kind of have to listen to me instead of reading my handwriting. Distance from the entrance. And that would have changed because he moved away from the entrance, but then he goes through that curve. I know, I'm sorry, I'm pointing at the screen when you can't see what I'm pointing at. Then he goes to that curve, and then he gets over to that dot over here, that dot right there. So, okay, well, what was I thinking? Why was I pointing? I can just point the mouse. So this was the curve right here. That's why I curved right there. Because if you're going in a straight line, that means you're going directly away from the entrance if it's at a constant rate. But then once he gets to this dot, from here to here, these 2 points are exactly the same distance from the entrance. So that's why the entrance, it stays the same from here to here because you're not any further away from the entrance. That's the entrance right there. But then after this dot, it's going towards the entrance, so it's going to rapidly get closer, but doesn't quite get to the entrance because you're going to pass the entrance, and then that means he's going to get further away. It's looking something like that. All right. Fourth question is basically about how would the last 2 change if he stopped at the slide. That just means it would have stayed the same right here for longer. If he had stopped at the water slide, his distance would not have changed from the entrance. This one would have changed because it would have gone across, because his total distance traveled is not moving at all. We're assuming he's looking without moving. If he's looking without moving, then his distance he's moving would have stayed the same, and then it would have moved again. All right, so that's question number 4. So getting to the homework tonight, which I know a lot of you have a lot of questions, so this is probably going to be a pretty highly watched video. Where does f of x equal g of x? Well, they equal right here. If it had said when do f of x, or what value of x is, that means when, then the answer would have been 2. But since it says where, the answer is 2, 5. That's where they intersect. What is f of 4 plus g of 4? F of 4 is 7, and g of 4 is 6. 7 plus 6 makes 13. So when I'm finding f of 4, I just start at the origin, go right 4 for the amount of time, that's x. F of 4 is, and then go whatever it takes to go up or down to get back to the function, that's what that represents. So that's the dependent answer to that independent variable, with 4. What is g of negative 2 minus f of negative 2? G of negative 2 is 1, because I went right here. It looks like 1. And minus f of negative 2. F of negative 2 looks like it's about 3. I think it's slightly more than 3, but I'm just going to say it's 3. Yeah, close enough. 1 minus 3 is negative 2. Done. There's your answer. I'm going to erase all this because I do want you to watch the video and not just scroll to the end and see all the answers. On what interval of g of x is greater than f of x? And g of x is greater than f of x during this time span. Notice that g of x is above f of x right here. It's still above right here. It's still above right here. It's still above right here. Right here is when they become the same. Now g of x is below. We can assume that f of x is going to continue in that same manner. So this piece represents the entire time when g of x is above f of x. So when is that? When? When means we're talking about the independent variable. 2. 2 is when it stops being greater. So x has to be less than 2. Okay, pen, why aren't you working? There we go. Less than 2. Anytime x is to the left of 2, g of x is above the f of x function. All right, once again, I'm going to erase, but this time I'm erasing because it's hard to see the graph. This is the toughest question of them all. Sketch f of x plus g of x on the graph provided. So what you're going to have to do is you're going to have to actually solve a bunch of problems in order to graph this and see that maybe it's going to be a linear answer. And so if I do 3 or 4 of them, I can see what the answer is. All right, it's easiest to start at 0. Let's start at 0 as our starting point. F of x is at 3, g of x is at 4. 3 plus 4 makes 7. So the new function is right here. But that doesn't tell me the rest of the answers. So I'm going to go to 1. F of 1 is 4, and g of 1 is about 4.5, so that'd be about 8.5. So I'm going to put that answer about right here. I'm going to work my way, I'm going to do one more, 2. F of 2 looks to be 5, g of 2 is also 5, 5 plus 5 makes 10. Now let's say 10 is about right there. Now let's work backwards. F of negative 1 is 2. G of negative 1 is about 3.5. 2 plus 3.5 makes 5.5. So the answer would be about right here. Now, you should notice now that there's kind of a pattern going on here. Looks like the dots are going in a linear line. Let's do at least one more just to make sure. Let's do f of negative 2. F of negative 2 is 1. G of negative 2 is about 3. 1 plus 3 is 4. All right, I think we've got enough points now that we can determine that the answer is going to be a straight line. I kind of missed it, but there's the answer for f of x plus g of x. All right, so that was the hard question of the day. Let me know if you have any questions. Hope this video helps.